So today we're talking about 10.1 squares and square roots. And the good thing is that this is something you already know. If I asked you what it means to square a number, I bet you know that squaring a number means multiplying it by itself. So for example, 5 squared is 5 times 5, it's 25. And I bet you also know how to take the square root of a number. The square root of 25 is 5 because 5 times 5 is 25. The square root of 25 is 5 because 5 times 5 is 25. And we know that this symbol here means square root. So numbers like 25 are called perfect squares. Can we think of any other numbers that are perfect squares? Like, is 1 a perfect square? Or 4, or 9, or 16, or 25. All these numbers are perfect squares because 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 6 times 6, 7 times 7. We've done this before, right? 8 times 8, 9 times 9, 10 times 10. And then these are some of your lesser known perfect squares. 11 times 11, 12 times 12, 13 times 13, 14 times 14, 15 times 15. Then put ... because we can still keep going. But the main ones we really want to know are these perfect squares down here, the ones that are less than 100. And we want to know the difference between when we say the square of a number, meaning multiply it by itself. So the square of 7 is 7 times 7, or 49, versus the square root of 81 is 9. Squaring a number is timesing it by itself. 8 times 8 is 64. Square rooting a number is finding that number to, wait a second, 39, I don't know the square root of 39, right? But I know that the square root of 36 is 6, and I know that the square root of 49 is 7, and 39 is between 36 and 49, so the square root of 39 is between 6 and 7. Which consecutive integers? That question gets people sometimes. Another way to do it is to do square root of 39 on your calculator, and you'll see it's 6 point blah, 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 and 6 point blah, blah, blah is between 6 and 7. So now we're going to go through and do some simplifying of square roots, and some of them are easy because it's a perfect square. Square root of 25 is 5. Square root of 100 is 10. And notice once I take the square root, I don't have the square root symbol anymore. So sometimes, I don't even want to write this down, but sometimes a mistake I see is people will say that the square root of 100 is the square root of 10. No, the square root of 100 is just regular 10. And that's going to be important when we get to one like the square root of 75. That is not one of our perfect squares, right? So what we're going to do is we're going to simplify this square root, and you've seen this before. You're going to look for, on our list, the biggest number that goes into 75, which is 25. So we're going to break down square root of 75 to the square root of 25 times the square root of 3. Because 25 times 3 is 75. Notice I still have square root symbols. Then I'm going to take the square root of 25, which is 5, and I don't know the square root of 3, so that stays. So simplifying the square root of 75 is 5 root 3. Trying again with the square root of 18, you're looking for the biggest perfect square that goes into 18. Well, 9 times 2 is 18. The square root of 9 is 3, and then we're left with square root of 2. Couple things. I usually put the perfect square first, or I say we're separating it into one we can do and one we can't do. And then we actually do that square root. And you notice I crossed it off. I find that that's helpful to cross it off and say, well, what is the square root of 9? It is 3. Now 48 is a tricky one because people think, well, 8 times 6 is 48. True, but neither 8 or 6 are perfect squares. And then people say, well, 4 times 12 is 48, and 4 is a perfect square. True, but 4 is not the biggest perfect square that goes into 48. The biggest perfect square that goes into 48 is 16. And the square root of 16 is 4. So it's 4 root 3. Now, if you wanted to use the 4 and 12, I can show that over here. You can, but it's going to be more work for yourself because then you're going to be saying, oh, wait, I can break down the square root of 12. The square root of 12 is square root of 4 times square root of 3. The square root of 4 is 2. 2 times 2 is 4. So you'd get the same answer. It would just be longer. So it's easier to choose the biggest perfect square. Same thing happens with 72. Like people think right away, 9 times 8, right? 9's a perfect square. True. And you could get the right answer that way, but you will get the right answer faster if you choose 36 and 2. The square root of 36 is 6. We're left with 6 root 2. And again, this is something you've done already. Square root of 20 is square root of 4. Square root of 5. The square root of 4 is 2. 2 root 5. Now it starts to get a smidge harder here where we put a number in front. 8 root 12. 8 root 12. Well, it's fine. You're still going to break down the square root of 12, root 4, root 3. You're still going to say, well, the square root of 4 is 2. And then just at the end, you're going to multiply in that 8, 16 root 3. Same thing for the next one, 3 root 28. The 3 is just going to hang out for a second. Square root of 28 is square root of 4 times square root of 7. The square root of 4 is 2, and 3 times 2 is 6. Last one here in this row is square root of 300. I think you'll agree that 300 is 100 times 3, and that the square root of 100 is 10, and 5 times 10 is 50. Now some people will say, do I have to show all that work? It's up to you. Sometimes you can do some of this in your head, but I would recommend showing the work. The last row's got some harder ones where I say like, okay, we got to multiply those together first, which is 144. And then you're like, oh, wait, that's a perfect square. Square root of 144 is 12. So we kind of put it together, then take it apart. Same thing with 16. Put it together, then take it apart. We've got outside numbers, inside numbers. We're going to multiply our outside numbers together. 3 times 4 is 12. Multiply our inside numbers together. 2 times 8 is 16. And then again, lucky, we have a perfect square. The square root of 16 is 4, and 12 times 4 is 48. Same thing here, outside, inside. 7 times 4 is 28. 12 times 6 is 72. Well, we did the square root of 72 already. Is square root of 36, square root of 2. The square root of 36 is 6. Yikes, I don't have a calculator on me, so I got to do this the old-fashioned way. So it looks like it's 12 and 4, 168. So 168 root 2. Next one here, 5 root 2 squared. I'm going to put a star by this one, 5 root 2 squared. So we know from earlier to square something means to multiply it by itself. So if we multiply 5 times 5, we get 25. And the square root of 2 times the square root of 2 is the square root of 4. And then square root of 4 is 2. 25 times 2 is 50. Last one here of these harder ones, 3 root 10 squared. So again, I write it 2 times, 3 root 10, 3 root 10. 3 times 3 is 9. Square root of 10 times square root of 10 is square root of 100. Square root of 100 is 10, and then 9 times 10 is 90. Ta-da! Now, sometimes we have decimals, and you've had decimals before, and I talk a lot about rounding to the nearest hundredth. But a lot of times kids have questions on what that means. So the nearest hundredth is 2 places after the decimal point. So for example, if I'm going to round 1.576 to the nearest hundredth, I'm going to look at the thousandth place, and I'm going to do my old 5 or above, give it a shove. 5 or above, give it a shove. So since 6 is 5 or above, it's going to shove the 7 up to an 8. 5 or above, give it a shove. And then here, 5 or what is it? 5 or below, let it go. Actually, it's 5 or above, give it a shove, less than, leave it alone, whatever. So here we get 1.57. Yep. Perfect. Here, that one's a tricky one for kids to round because you got the 9 and then you're like, oh, what does that do? So 9 technically rounds the 59 to 60. And then of course here the 6 is gonna, 5 or above, give it a shove to 1.61. Now here you see I have the squiggly equal sign, right? That squiggly equal sign. That's going to say approximate. And approximate means that I am going to do that on my calculator. And the directions when they want you to use a calculator will clearly say use a calculator. So here I'm going to type in square root of 54. And the square root of 54, 7.348, but 5 or above, give it a shove, is going to write 7.35 here. So we're going to round it. Similarly, I'm going to do square root of 26 on my calculator. Square root of 26 on my calculator, 5.099. That's going to round to 5.10. You could say 5.10 or you could say 5.1. It's the same. Similarly, square root of 75. Now I'm just typing it in. That one's 8.66. Next one's got a number in front, 8 root 12. I can type that in just as is, 8 square root 12. Enter. 8 square root 12, 27.71. Couple more. 3 root 10 quantity squared. I can use the parentheses keys. Parentheses 3 root 10 quantity squared. You can see it types in just like that. And then if I hit enter, 30. And I could do that one by hand. Wait, I don't think that's 30. I think I did it wrong. I think I gotta do my parentheses right. Let me see. 3 root 10. I need 2 parentheses here. Squared. Yeah, that's the right answer is 90. That's interesting. I'm kind of glad I made that mistake to show you, because here in the first one, it was just squaring the square root of 10 and then multiplying it by the 3, but I needed to square the whole quantity, so I needed that extra set of parentheses, so that is actually 90. And then the last one, I can use the parentheses, right? 7 root 12, 7 root 12, parentheses, 7 root 12. And I'm going to need double parentheses there, times 4 root 6, and again with a double parentheses, 237.59. 237.59. Okay, and the very last thing is just a quick true or false. Is the square root of 9 plus the square root of 16 equal to the square root of 25? People sometimes won't be sure. Well, you have to actually take the square roots first. Is 3 plus 4 equal to 5? No, it is not. But if I asked, is 9 plus 16 equal to 25, that's a yes. So I can have a true statement, but if I were to go in and put square roots around each number, then it's not true anymore. And that's going to be really important kind of moving forward in the chapter. And then at the end, I just said squaring a number is the opposite of taking the square root. So there we have it, squares and square roots.